Finally, okay, so this thing, what is this? AI model question paper, okay? Before explaining the other topics, I'll be just solving this model question paper. Okay, so see here we have this definitions, five definitions, okay? So we have this total Turing test. So let us see. I have made a PDF here, okay? You can see here, this is one PDF which I made myself, and this is one PDF like, what is that? Some guy had uploaded, and this is a textbook thing. Okay, so wherever theory is there, I'll just show you all these three things. So first, let us say Turing test. The simple definition for this, which I am explaining to you, is that it's not only Turing test. They have asked total Turing test. So first, just see what was Turing test. Okay, so Turing test was nothing but it was a artificial system, artificial intelligence system, which will make the machine exhibit human-like behavior, exhibit human intelligence. Okay, for example, the text feedback which we receive from an AI prompt. So it's like humanly, right? It's not like some computer type, like something like that. So that thing was basically Turing test, which will make a machine's ability exhibit intelligent behavior indistinguishable from a human through text-based conversation. That AI thing. Indistinguishable means it's not separate from human. Okay. So what is total Turing test? So total Turing test is nothing but what they will do here. It will just include additional sensor and physical capabilities. This means the machine must also demonstrate human-like abilities. For example, this robotic arms, some industries which where all the labor works is done by humans, I mean, sorry, robots. So it should also demonstrate not only it should exhibit human intelligence, but it should also demonstrate human-like abilities in perception and action. In perception means percepting from the environment, gaining knowledge from the environment. In action means from after understanding everything, what action does. For example, from sensor, it will see all the surrounding imagery thing. Suppose it has to do farming, it will see from the sensor, that is camera, it will see the tomatoes. If it is the color of the tomato, is it ripen, green, red, it is wrinkle type, it is ripen or not, it is damaged. And then from the action, what action you should do from that robotic arms, it will just plug it and put it in the sorting bin. So it will be some three bins, suppose. So no, not dustbin, just bin. So sorting bin. So in one bin is for ripen one is for damaged one, like that. Okay, so that's nothing but Turing test. Okay, then you can also see the definition here for Turing test: an assessment of machine's ability to exhibit human-like intelligence and behavior across multiple modalities, including text, speech, vision, and motor functions, to determine if it can emulate human interaction completely. So this definition feels more simple for me, where it will, unlike Turing test, where it exhibits only human-like intelligence. In total Turing test, it also demonstrates human-like abilities in perception and action. This much definition is enough. If you want to add more, you can say that this thing you can add here, where he said. Including text, speech, vision, and motor functions. Motor function nothing but robotic movements. For example, bike moving is also a motor function. Moving the arm, the robotic arm from left to right going there, that is also a motor function. If it is having legs or wheels going from one place to another, that is also motor function. Okay, I have made like dragged it a lot for during test. It's only for 1 marks usually. But if they are for more marks, you know what to do. What is logical positivism? So logical positivism, nothing but whatever this machine will do, right? That should have some logic. It should have some logic, okay? So that's nothing but logical positivism. So let us see here. I have made one small, like highlighted this thing here. Oh, it's not getting selected. So logical positivism is a philosophical movement. So it comes under fundamentals of AI, like those topic. So under which logical positivism falls under philosophy category. It was emerged in the earlier 20th century, primarily associated with the Vienna Circle. This is not required to write, but still, it asserts that only meaningful philosophical problems are those that can be solved through logical analysis and empirical verification. Leave the rest of the thing. Just remember, an AI should be capable to solve a given problem through logical analysis and empirical verification. It should have those things. So, if philosophy asserting that meaningful AI statements and hypotheses must be either empirical verifiable through data and experimental experiments as analytical true through logical and mathematical proof. So whatever the statement the AI generates or the AI gives us, it should be proved by where it went. It should be solved through or proved through logical analysis and empirical verification. Just remember, instead of just giving some random text, whatever the statement is generated should give us these things. Like it should be provable logically. It should be proved through logical analysis and empirical verification. At the beginning, you can also add that logical positivism is also known as logical empiricism. Okay. Then you can see is a philosophical movement that emerged in earlier 20th century. It asserts that only statements verifiable through direct observation or logical proof are meaningful. So it says that what are meaningful, how it is meaningful. You saw statements can be verifiable through direct observation and logical proof, which are meaningful. How it does is by this, yeah, I showed here, logical analysis and empirical verification. Tractable problems. So tractable problems are problems that can be solved in polynomial time. Okay, given polynomial, so this first two lines are enough for what to say definition for tractable problems. Tractable problems are problems that can be solved in polynomial time, meaning the time required to solve these problems increases at a polynomial rate as the size of input grows. Same thing is there here. And by the way, if you are hearing some background disturbance, I'm just sorry for that. I cannot do anything with that. So here, see tractable problems, the problems which AI can find solutions efficiently within polynomial time, ensuring practical applicability and stability as the size of the input data grows. Okay, so you understood, right, what is decision theory. Okay, so now I'll just tell once again, decision theory is nothing but a framework used to design AI systems. So how it should decide things under uncertainty, how it will make its choices. So here you can see here. Uh, okay, sorry. I directly went to decision theory. Sorry, I was saying tractable problems. So tractable problems are the problems you see here, which AI algorithms can find solutions efficiently within polynomial time. Okay, the problem which can be solved within polynomial time, and what that thing was here. So polynomial time meaning the time required to, so the time usually required to these problems are increases at a polynomial rate, which means it increases as the size of the input grows. So three things which it can be solved within the polynomial time, and then the time will increase, time increasing, the time taken to solve the problem increases at a polynomial rate, and that increases due to the size of input growth. Okay, we have here decision theory. Decision theory, it is a field of study that deals with making decision under uncertainty. So whenever there is some uncertainty, this part of thing comes here. So decisions are made under this. Okay, decision under uncertainty. It involves identifying the best course of action by considering various possible outcomes and probabilities and the associated utility or P. So see, possible outcomes and the possibilities is more than enough for you to remember here. So it makes decision on uncertainty. So AI algorithm or AI system should be capable of making decision on uncertainty by identifying the best course of action by considering various problem outcomes and their probabilities. Okay, so that's it. You can see this what is that? Here definition, and here also framework used to design AI system that makes optimal choices under uncertainty by evaluating possible outcomes, risks and rewards in correspondent both normative and descriptive model. See, what is the normative descriptive? Nothing but it is types of this. What is that? Decision theory. We have normative, descriptive and prescriptive. Now coming to neuron are the, so just let us read this. Oh, this definition: neuron is the fundamental unit of the brain and nervous system responsible for processing and transmitting information through electrical and chemical signals. This is about a human body. Each neuron consists of a cell body, soma, dendrites, and an axon. Dendrites receives signal. The dendrite is that hairy structure, okay, like branch type structure. Receives signal from the other neurons, while the axon transmits signals to the neuron or muscle. Okay, neurons communicate a junction called. Hey, why is it explaining only about? So it's here. You know, artificial. The artificial evaluate. What is that? Equivalence of biological neurons is neural networks, where each artificial neuron processes inputs and transmits output to other neuron, framing the basic of learning and pattern recognition in AI systems. So wait, in textbook, we can simply search this Neuron. Don't tell me the spelling is wrong. Okay, neuroscience. See, neuron is coming under this place. So first thing, neurons. So see here, in brain patients. Okay, for brain what is my brain considered of no, say, or neurons, but it was until developed a staining technique allowing observation of individual neurons in the brain. This technique was used by blah 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 in his pioneering studies of the brain's neural structures. Okay, okay. So usually they say they have showed the neuron. This is dendrite, or we just said structure of neuron. Okay, so here it's nothing but some device which neural activity is. So I think this thing is. This holds easy and good definition. The artificial equivalence of biological neuron is neural networks where each artificial neuron processes inputs and transmits outputs to other neurons. Same like human normal neuron from okay see here in one end okay this will generate transmit the signal output type and this is for input type this place. So here another same whole thing will be here like connected in chain manner. So what will happen here, it will give signal, it will take generate the output and it will leave the signal like this. Okay, same thing they are saying. Transmit outputs, inputs, processes inputs and transmit output to other neuron, forming the basic of learning and pattern recognition in AI system. Neural network transmitting okay processing input and transmitting output to other neurons, then basic of learning and pattern recognition in AI. Okay, that was this first question in this thing. Okay, let us move to second question. Okay, so see what to say in what is this foundation of AI. So they have said like explain the significant contributions of various branches of foundation of AI. So you see in this this thing they have just explained a few things, not all the things. So if when it comes to this textbook thing, so see here you have linguistic, that is eight, total eight are there. Okay, but when you like generate answers from AI also by providing this textbook as a source to thing, even it has like generate only six. Whereas in this we have here philosophy, mathematics, computer science, neuroscience and cognitive science, which is four, linguistic only five. So this guy what he did for 10 marks he just explained only five. So here what you can understand if you study more. So see here I have done all eight. Okay, so as you can see here, if okay, first let us study from this and then just I'll remove this part. So see here, usually philosophy. A philosophy has provided foundational questions and framework for AI. So this you have here this formal logic, mind-body problem, and epistemology. Epistemology is basically like getting the knowledge. Okay, the origin starting from that thing for AI. So the study of knowledge, its origin, and how it leads to action has made crucial in developing AI system that can learn and make decisions. Whereas in this place, when he talked about philosophy, even he has written the same thing. First, epistemological examines and the nature and scope of knowledge, which has influenced AI's development of knowledge representation. So you know how knowledge representation, that knowledge representation, knowledge representation is nothing but representing the knowledge in various form. So it can be either pictorial using some if we have to represent knowledge to AI, that's different. We'll be using logical kinetics and that quantifiers, etc. So see here developing AIs that can learn and make decisions. So here what it said, knowledge representation, reasoning and learning. Key philosophical questions about what constitutes knowledge and how it can be acquired, how our what is this man acquired have directly impacted the design of systems than logical. So just see here epistemology, what he has said, the study of knowledge, its origin and how it leads to action has been crucial in AI developing AI system that can okay. But whereas when I made answers like right from the textbook, Even though in textbook it says here, if you go to up, where is this? Okay, okay, here it's somewhere here. Mathematics and philosophy. Yeah, see here. So here epistemology, where is that thing? Philosophy. Let me see. Okay, that's not there actually in this. Wow, that's great. But still, epistemology is nothing. You can just write something on that philosophy also. So if you see in this thing, it's not that difficult. It says that it starts with logical reasoning and ethics. Ethics, let me just say what is ethics. Ethics, you know, right? Ethics should be ethical. Ethical thing means it should not be harmful or it should not be biased. It should not contain anything which will affect someone's life or harm someone's life, affect the society, blah blah blah. So see here, philosophical discussions on ethics help guide the development of AI systems that are fair, transparent, and beneficial to society. So, what philosophical discussions on ethics? It will help us in what fair, transparent, and beneficial to society. Okay, so it should be fair to society, beneficial to society, and transparent to society. How this can be achieved is by discussing philosophical discussion on ethics and logical reasoning, logic and reasoning. Philosophy has contributed to AI through the development of formal logic, which is essential for creating algorithms that can reason and make decisions. You can also write logical positivism here, which you had already studied. Next, you can go for mathematics. So let us hear for mathematics what is it. Mathematics, it has talked about algorithms, linear algebra, and probabilities and statistics. Algorithms, mathematics provides the theoretical foundation for algorithm used in AI, including those for search, optimization, and learning. What we have said, algorithm, the development of algorithm which are step-by-step procedures for calculations is fundamental to AI. So basic algorithms, we can say a finite set of step-by-step procedure for solving any computational problem also. Then probability and statistics. These are crucial for dealing with uncertainty and making predictions based on data. Probabilities or whatever the data you have. According to that data, you will make some assumptions. Even these fields help in dealing with uncertainty and making predictions, which are vital for machine learning and data analytics. So whatever the possible data outcomes are there, it will collect all the data, and according to the data, it will just remove possibilities. Sometimes if it gets the proper answer, it gives that proper answer. If not, what is it? It gives, or it can be like this. So multiple answers will come. Okay, let us see what he has written here in mathematics. So I'm just trying to like give you things from 3 to 4 sources so that you will understand and then write. So see mathematics, what are the formal rules to draw a valid conclusion, what can be computed, how do we reason with uncertain information. These questions just keep in mind how you can solve these questions, just those things are nothing but here. So see algorithms are there, incompleteness, just leave it computable. In NP completeness, it comes from the analysis design of algorithm and probability. So basic thing you can see from each thing you can explain 2 parts, right? It has asked all those things. So you can explain probability and algorithm. You know what is probability? Total number of outcomes. Don't write that nonsense things. Max, how probability is used in solving anything. So whatever the total every data, you have to collect all the data and removes the number of outcomes which can be generates the possible outcomes and selects the best solution or best outcome. Okay, an algorithm also we have seen here. Then here, probabilities and statistics fundamental for dealing with uncertainty in AI, enabling the development of probabilistic models and algorithms for tasks like classification, what is this, regression, and decision making under uncertainty. So decision theory was there. You can put the decision theory under mathematics also. Techniques such as Bayesian networks and Markov decision process stem for this branch optimization. Okay, so much exercises. Yeah, okay. It didn't explain much. So see here, optimization is also there, but here it's very simple, right? Even in the textbook we had probability and algorithm. So this suits best. Then psychology. So psychology consists of cognitive modeling and learning theories. So psychology contributes to AI by providing insight into human cognition, which can be modeled and replicated in AI system. So basic thing you can write under psychology is that studying human behavior, human action in person and then applying those results or those observation to model or replicate in AI system. Okay, that is cognitive modeling. Then another, say what I said generally you can just write off without mentioning any heading. Then we have learning theories, understanding how humans learn, help in developing machine learning algorithms. So give a problem to the human, just observe how the human is solving it. That same thing you can apply to this machine also. So basically that is what I said. Observing in human, what human does, how human reacts, the action human does, how the way human thinks. This comes under psychology. You are observing the human. Whatever you have observed, you will put for this machine thing, and you will make it work. Okay. So see here, cognitive computer science. So he didn't talk about psychology. Here we'll see cognitive models, understanding how human thinks and learn has inspired the development of AI that mimic human cognition. Behavioral studies, insight into human behavior, help in designing AI systems that can interact naturally with humans. So I'm just giving you idea. Okay. Once you understand, you can write whatever you want from your own. Just remember key points. Understanding human thing that and all again. Okay. I hope psychology is done. Then you have what is this? Computer science, programming languages, data structures and algorithms. See, there is easy thing this we can fill here. So what I'm saying, totally 8 are there. Either you can explain any 5 properly with proper definitions, example, or else with proper like, or else you just explain which you know more, and if you feel like it's less, then just add anything else. So see, computer science, programming language, development of languages and tools specifically designed for AI application. For example, Python. You can just give the example of Python, how Python is used generally in this model word for this, that, and all. And then you have this data structure algorithm, fundamental concept in computer science that are essential for efficient AI system design. So see a data structure algorithm. So you can just simply talk about the data structures which are used in various parts of thing, and algorithms, how it is under algorithms. So data structures will come. So see here, here computer science. So this has talk, yeah, computer science is there here. In neuroscience we will talk about that. So programming language, development of languages and tools for implementing AI algorithms. So programming, we can implement or use many languages to build a AI algorithm. Then data structures, efficient data storage and retrieval methods are crucial for AI application. For example, you know that linked list and all, how it is used to like move from one, retrieve one link to another node, one node to another node, and then stack and queues, how it processes and all. That thing you can put on a data structure. And computational complexity, understanding the limits of what can be computed in a reasonable time, helps in designing efficient AI systems. So computer science, you can simply put this complexity, how which algorithm is more efficient, efficiency of an algorithm, which we have already studied in ADA, right? So it's not a problem. Then neuroscience. Okay, here what they have said, neuroscience, neural network and learning mechanisms. So you have already not learned about neurons, right? Neural network, the structure and function of neural network in AI are inspired by the human brain neural architecture. Nothing you have to explain. Just say that it is neural networks are there. That is inspired by humans' neural network or neural architecture. How it will process the input and transmits the output. Okay, same thing you see here. Neural network inspired by the structure and the human brain, and the neural network are a key component of many AI system. Neural network, because it should be connected, right? Worldwide connected. That is also you can say neural network. Internet also you can say as neural network. Brain, okay, neuroscience brain. So basically, when brain comes, you can simply say we are studying human brain, how it works and on, and putting it. Computer interfaces. Research in neuroscience helps in developing interfaces that allow direct communication between the brain and computers. So neuroscience also, artificial intelligence. We are making a machine or a system which will simply read your brain, interact. We can interact brain and computer directly, now like that. So something just remember like that. So see, 5 are done here. Okay. Do we have anything here about, okay, computer science also you have given, just read here. Machine learning and algorithms. Yeah, machine learning is very important thing to mention in computer science. Machine learning, what from feedback which you give from that cycles and all, it will be learning. Neuroscience, here you just read out, and then linguistic it has said. Okay. Oh, computer science. So linguistics, then remaining linguistic here also it's there. Natural language processing. Okay, NLP. Then engineering economics. So linguistic provides the foundation by for understanding and processing human languages, enabling AI systems to interact with human in any natural way. So if you're implementing AI, it should be like every person should be able to use it. Okay, that's what it says. What I mean is, so AI is there any part of world. I'm not talking about the rural or rich people here. I'm just talking about different countries. Suppose India. In India, you have various in variety in these religions and people language, like mother tongue. If you are Hindi, if you are English, Tamil, Telugu, Malayalam, Punjabi, so many are there. Okay, Kannada especially. So whenever a person is accessing, for example, Google, so it doesn't know what to say, so it will simply talk in Kannada, and that machine should understand that language, right? So that comes under linguistic. NLP is the main key for that natural language processing. Then syntax and semantics, understanding the structure and meaning of a language is crucial for developing effective NLP systems. What has the same thing? Study of language structure and meaningful meanings helps in developing algorithms that can process and understand human languages. Syntax and semantics. Oh, okay, done this thing. Where is it? How can I cancel this? Okay. So see here, engineering, robotics and control system. Engineering principles are applied to design and build robots that can perform tasks autonomously. Okay, same thing. AI engineering can you can put under this complete hardware category part. We are making robot, machines, etc., etc. Artificial system is different and the actual hardware system is different. Okay, artificial system. Suppose a robot is here. You are just giving a soul for that robot, soul for that machine. That soul is not artificial system. That AI thing, which will give it guide this robot what to do, what not to do, etc. etc. Economic decision theory. See, decision theory comes here under economic and game theory used in AI for developing strategy in complete environment. You can simply talk about how games are created and here how economic contributes to AI through decision theory, which helps in making rational choices under uncertainty. I hope I have explained all this fundamental etc etc and I have given you proper knowledge about whatever is there. Okay, just use those keywords, all those things. Here also you can see mathematics is done, probability, economics is there, decision theory comes under economic, game theory. So simply you can talk about economics, decision theory we had already studied in the first question, and then we have here what is that, game theory, how games are created. Then neuroscience, neuron. Simply talk about neuron and neural network, how it is used, inspired by human, etc. Psychology, behaviorism, how human, studying human. That's it. Cognitive psychology, etc. Much is not required. You can simply talk about how humans are observed and then implemented that thing in AI. Computer engineering. Let's see what's there here. No keywords. Okay, there are no keywords, but you can understand, right? Programming languages, important thing. And another, even I forgot what was that, for computer science. Okay, data structures, algorithms. Then where is this textbook? Then what is this? Control theory. Okay, it didn't talk about that. Linguistic is very simple thing. That's it, done. So what's the last? Gives P specification of biometric authenticated system. Okay, let us see here. P specification for a biometric authentication system. Okay, so see here, basically whatever performance measure, this one, environment, okay, actuator, sensor, that's it. Four things are required for this piece. What they have said. How do I remove this? By this, yeah, nice. Okay, give this, okay, only 5 marks. Just remember one thing. For a biometric authentication system, okay, what kind of biometric authentication system we are talking about here? So perform accuracy of authentication, speed of the authentication process, user satisfaction, security level. So whenever you want a biometric, like password, phone, if you have to open your screen lock, okay. So how it should be? It should not take so much time, processing time. It should be very easy to like understand what you have to do. User satisfaction. That's what. How the for animation for screen finger, that thing. Just understand. Then security level, others cannot just open. For example, face recognition is there. Someone, it should not show one photo and then open blah blah like that thing. So that is security level, user satisfaction, speed of authentication process. So this falls on the performance level. So P specification mainly consists of the performance level of whatever the thing it is. The environment, okay. So see here, environment, this can be anything, various lighting conditions. For example, it is a camera face unlock thing. So you can say how light is affecting different user demographic, age, gender, etc. So whether and age, so wrinkles are there or it is just a baby, how it is. Then varied physical environments, indoor and outdoor. Then network condition, online or offline. So how possible things are there for some biometric authentication. You can simply say that what's it? The person is in or out, outdoor or indoor, age, lighting conditions, that indoor. Uh, Simple things, okay. For biometric, I think it can be a fingerprint, faces. So be specific. If you're talking about fingerprint, then talk about fingerprint. How environment is there? A device. We need a fingerprint scanner. Scanner is required. Okay. Etc. Etc. Okay, so then actuator, display screen for user interaction. So this is very simple. Environment, whatever is there when you're thinking about biometric authentication, whatever is your environment that you will talk about. Whatever is there, whatever is happening, a device is there, or if you are in a shadow place or in a sunny place, if it is a male, female, gender detection, age, everything. Okay. Actuator, display screen for user interaction. So what actuator is nothing but what actions will be visible for us, what actions are done. Okay, for basic we need one display thing to show the what is that, whatever the display is happening. Then signal to grant or deny access. Then feedback. So suppose fingerprint was wrong, it should display right actuator, wrong error, this thing, or face is not recognized, face was not recognized. So that is nothing but actuator. It should signal to grant or deny access. Then feedback mechanism like elite indicators and sound alerts. So if you do more time feedback mechanism, so try for example password you're doing, error, try again. So feedback mechanism. So it's saying like that, try again. And then if you multiple times, if you just put the wrong password, it will just log. That comes under again performance measure, security level. Okay. Then sensors, very simple thing, how it will authenticate, what is required to verify authentication biometric. For example, camera, you can simply say biometric sensors which will be there in our phone, that is a fingerprint scanner, facial recognition, camera. You can simply like sensors like camera, fingerprint, biometric sensors for fingerprint scanner. Then environmental sensor, light sensors to adjust camera settings. So environmental sensor is nothing but it should be able to adjust the light thing, everything. Basically camera itself. So however we are, it should adjust that camera thing to understand or recognize the person. And then network sensor to check connectivity status. Okay, I hope you understood, right? Piece measurement can be, specification can be given for anything. We also have a question for tomato classification. We can also make it for a teacher, any like day-to-day life, any problem. Okay, everything. How application is opening. For that also you can do piece classification. For farming you can do. For driving a bike. For anything automated vehicles. For everything piece specification can be done. How performance measure, environment, actuator, sensor. Just remember performance, how nice it should be. You will be talking about the efficiency of that particular technology. Environment, whatever and all is there. For example, if you are talking doing some labs are there, right? What is the environment of lab? So many systems are there, lab teachers are there, students are there, chairs are there, everything you'll be mentioning, that is your environment. Actuators, how things are actions are taking place here. So computers, it will display how actions are there. If someone is misbehaving, teacher will do something, right? That is also an action, right? So that kind of actuators. Then sensors, how we are interacting, how whatever the problem is happening, how it is seeing from, okay, from the environment, how we are perceiving in the sensor. We have that basic model also, right? Okay, that's it. Done. I don't think much things are required. So then, is it done? Yeah. So first question is done. Okay, nice.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.